So we were chatting last time with JJ Hermes from the University of North Carolina about these hypervelocity stars, which are stars that have been in some kind of explosion and been flung all the way out of the galaxy. These stars are actually white dwarfs, right?
Yeah, they're either white dwarfs or subdwarfs or, something that's not quite what you think of when you think of a star like the sun. They're at the end of their life, they're kind of low mass, they've maybe lost some of their outer layers, likely due to this explosion or some other just, evolving toward the end of its life. So we actually talked a little bit more with Dr. JJ about these white dwarfs and what's going on.
I think one of the really interesting things about these stars is people are arguing whether or not so when a white dwarf blows up, a white dwarf is the endpoint of low mass stars. All stars that are about 8 times the mass of the sun or less will become white dwarfs. And when one of those white dwarfs gets above about 1.4 times the mass of the sun, no longer has enough pressure to support its gravity, and it blows itself up. So when people talk about type 1a supernova, which is what we're talking about, that's what we're talking about. So people are arguing whether or not these really fast-moving stars that we're finding are actually the white dwarfs that blew up. If a little bit of that star remains bound, if it's an off-center explosion, you can get a bound remnant of about zero point 0.2 or zero point 0.3 times the mass of the sun. So a lot of people, myself included, actually, I think that's the best explanation for what we see in some of these cases. Whereas in other cases, it's pretty clearly the companion to that white dwarf that didn't blow up, but because its companion blew up, it got slungshot. And so I think that's going to be one of the next really interesting frontiers of this field, is to try to figure out, is this actually the companion to the star that blew up or the star itself that blew up?
So dumb question, like what kind of stars typically are the companions? Are they like main sequence?
Yeah, so I think probably in these cases, for them to get such high velocities, they have to be in an orbit less than an hour. And so to get two stars in orbit around each other in less than an hour, the companion also has to be at least partially degenerate or at least partially evolved. And so in a lot of cases, these are probably what we call hot subdwarfs, which is basically just the stripped core of a giant star. And so that's probably what most of the companions are, for them to be in such tight orbit.
Okay, so that's why it's non-trivial to tell the difference between that and a white dwarf, right?
Yeah, exactly. Yeah.
The other aspect of this, and something that's near and dear to my heart and stuff I've worked on for many years, is there are many flavors of type 1a supernova, and there's many models that can try to explain the type 1a supernova. And I think one of the really powerful aspects of this work that JJ and Ken Chan and others are working on is looking after the supernova and looking at these stars that are flung out or look funny, using this brand new amazing data set from Gaia. You can start to build up statistics, and you can actually say, okay, well, if we see this mass stars moving at this speed with this amount of neon, that same fraction of type 1a supernova explosions from the explosion side that I used to work on looks like this kind of flavor of type 1a. And you can start drawing those connections and say, all right, about 10% of the time, this is the kind of star combination we have that explodes, and this is the kind of star it flings off, and 10% of the time, that's the kind of star we see moving really fast in Gaia. And so that's where I think a lot of this could be really interesting, is starting to make those connections and connect the dots between this is the kind of star that exploded, this is what it looked like when it exploded, and this is what it looked like after it got flung away.
Yeah, that's really cool. So the reason I wanted to talk about this is I actually have an inside scoop in that a few weeks ago from the SOAR telescope in Chile, which we have access to here at UNC, we found another one of these hypervelocity stars that's moving so fast it's leaving the galaxy, and its abundance patterns are almost identical to the one we found about a year and a half ago. And so whatever made this thing, it did it almost identically in another case. So this is basically a new class of star. And so it's really, really fun to try to piece together all these puzzle pieces to figure out what on earth we're looking at and what made it in a uniform way. And so, we're probably at least a few weeks or months away from getting that all the way through the publication process. But it's really, really exciting and quite fun.
That's really cool. As I often say in astronomy, there's only 3 numbers, 0, 1, and lots.
Yeah, exactly.
Yeah, one is an anomaly, two is a class. That's what supernova people usually talk about.
Yeah, how many supernova classes are there now? And there must be dozens, right?
Had this discussion on Facebook and at bars with other astronomers, and I think I've gotten up to at least 15, possibly 20, depending on how thin you want to slice things.
Well, you mean you've personally classified 15 or 20 different types, or that's how many you've seen in the literature?
Those statements are true. I have classified a lot of stuff. I could slice and dice observations into solidly 15 or 20 categories.
Yeah, that's fun.
Well, you supernova people are kind of weird because don't you have like subclasses of type 2 that are actually not type 2s and nonsense like that?
There are many badly named subclasses, I fully admit. Yes, where people just throw on letters and Roman numerals almost willy nilly.
Nice. I mean, and obviously galaxy people are nothing like that.
Well, there's a phenomenology of anything when you start discovering it. You have to try to put them together to piece together what it all means. And
The first few original classifications of supernova back in the 20s, 30s, and 40s were totally reasonable and made sense at the time. It's just once you get thousands and tens of thousands of more observations, it breaks down quickly.
yeah,
Well, thanks, JJ, for chatting with us a bit more about white dwarfs and Type 1a supernova, something that I've thought about for many years and still think about, even though it's not my job. So thanks for joining us. Cheers.
cheers.